I got number one, homework answers. It'd be nice to get them, right? Yeah, well, you do. They are all on Teams. Zoom knows. When they go and click on the homework questions that are there, you scroll down, all the answers are there. So you can, so that means you can check your work every day, okay? Now, what you hand in here are not just the answers. I know what the answers are. They're in red. Oh, earthquake. How's that? I can find the answers, right? So you got to show the work in to get to the answers. That's what you hand in to me. Okay, make sense? Yeah, good. I think that might help in case some people are having struggles along the way, not sure if they're doing it right. You check on Teams, answers are there, and that might give you the secret. And if it doesn't, then you come and talk to me. Yeah. Okay. Zoom, you had something to say?
Yeah. So from the homework, the multiple function. It's the 24.
Question
Number
1 4.
24.
24.
Yeah.
Okay, I might get to it later today, all right?
Yeah, okay.
Show you the new stuff and then we'll see. Multiplying what though? Radicals, exponents? These ones or these ones?
No, the second one. Not square. Square root. No, not this one.
Not this. We'll come back to it. Okay. So
Okay.
I'll put that up on the screen somehow today. Okay, so that's good. That's good for you. Then up on the screen, what do we got? Yeah, this from last day. A quick scroll for you to see, to remind you where exponents come from, how to multiply them. Now, this came up in the homework from someone. They sent the chat in. So I'll put this up on the screen for now. If you had 3r squared, this too applies to everything, right? Because the brackets capture it. So this means 3r times 3r, whatever's on the inside there, right? And what do you get for an answer just for fun?
6R.
What do you get when you multiply the numbers together?
6R.
I'm going to go with 9. 3 times 3, get the 9 there. R times r, you get r squared. Now this is different. It looks the same, but the squared is on the r only. So that actually means this. 3r times, or 3 times r like that. Okay, squared is on the r only. What do you get? 3r squared. Okay, came up. Back to the screen. Yeah, all of these, we worked through them yesterday. The video is now up. I uploaded to the channel. Channel link is on Teams. For you new people, you can go and find it. And then you get to help me become a YouTube star. I got with my 10 subscribers. Yeah, exactly. The first day I doubled it. I had 1 and then 2. Double. It's good. All from last day, right? Okay, cubes, split them up, dividing. That's like that. What do we got for today? Oh, I guess any questions? Something like this? Any questions from last day? No? Okay. And this is the new day's stuff. What we're going to do is put, just to show you for today, just to get you started with this first topic, how to convert from exponents with fractions to like square root things. Couple of things. It looks scary, which is why I'm just giving you a little bit today, and then we'll do a little bit later. But then the main part's going to be on this negative root stuff. What happens when you get a negative in the exponents? Okay. So first thing is converting. Look at that. Up in the exponents, you might have a fraction up there. Might be a half, for example. They got n in there just to be math-like, right? Okay. And so what happens is whenever you have whatever number is on the bottom here ends up being part of the radical, part of the root that's there. So we're taking the root of x. X goes on the inside. Because it's a 2 there, it gets a little 2 here. Not a big 2 in front. It's not multiply. It's just telling you if it's going to be a square root or a cubed root or fourth root or something like that. Okay, that's what this shows here. So because it's a half, we get a 2 there. And this actually means this one is the square root, okay? And what you will normally see is like we drop the 1 sometimes, we're going to drop the 2. The only radical where we do that with. So if ever you see something to the power of a half, it actually means square root of whatever that thing is. Okay, so as a little example, right, this would switch to something that looks like that. Right, that's the point of today, just being able to switch. And what does the answer happen to be? Happens to be 2, right? Okay. Sure.
So if it's like x and 1 over 3 to the power, so it's going to be like cube.
Cubed root, yeah, that was the next example actually. You know, so show you something you know. The next one is going to be, what if it was like this? X to the 1 over 3. Okay, so watch where the bottom number goes. It goes there. And yeah, this is now is cubed root. It's exactly what it is. So if you happen to see this one day, the cubed root of 8, or 8 to the power of a third, it means the same thing as that. Happens to be 2, right? Point is this part though today. Look at here. Instead of having a 1 on the top, has a different number on the top. Okay, so instead of a 1, it could be a 4. Right? So we just got to be careful where those numbers go and what they mean. Right? Let's say you have x to the power of 4 over 3. Okay, the 3 goes in the regular spot, just like that. X goes on the inside. Now the 4 can go in one of 2 different places. The 4 can go on the inside with the x so that it looks like this, or it can go on the outside of everything, or it can go like that. They both mean the same thing. And if I have to show it to you, if I have to prove it to you, I will. Okay. But you can see it starts to look pretty ugly, right? Maybe even a little scary if you haven't done this before. So that's why just a little bit today. But maybe just to show you that it's true, let's take a look at our, let's make x equal 8, and then work through it this style first and then this style. So you can see that I'm not telling you any lies, all right? Okay, so we'll do the first one first. Let's say we got 8 to the power of 4 over 3. So I'm saying we had the 4 on the inside first, just because, right? That's the way it works. Well, this is pretty big. Can someone help me out what 8 to the power of 4 is? I think I know.
It's 4,098.
98, 96?
Or wait, 96, yeah.
Yeah? 256? No.
No, it's 8 in the fourth. The fourth to the power. So it's, yeah, I think it's 4,000.
Yeah.
96.
4,096. It is. The way I can't do eights. This would be 64 squared and a little awkward, right? 8 times 8 and then another 8 times 8 and then multiply those together. I happen to, as a math teacher, I just happen to remember, I think I mentioned it before. 2 to the 10 is the computer one, 1024, or at least the old computer, right? And so then it's, in my brain, this is 2, 8 is 2 to the power of 3. With the exponent rules from yesterday, this is now 2 to the power of 12. Right? Multiply these exponents together from yesterday. So I get up to 224 and then times an extra little bit. Okay. So this ends up being 4096 under there. Cubed root of 4096. Right? Okay, so no idea what this is. Can you guys help me out? Even Casio is okay. Casio is okay for this if you like. Let's see. I think you had something good there, actually. What did you just say? Is that what it is? There might be a little trick to this. Mm-hmm. Yeah, 4,096. It is this. Now I got it. Where's my calculator? What's that? 16? Yeah, that's with some tricks that I'm not showing you yet. I'm getting 16 for this actually. Okay, so that's not bad. So from this first version, and you might have to check that step there. This first version, I'm showing you that I get that it's 16. So let's do the other version where we do the cubed root first and then 4 on the outside. Okay. It's easier actually to do, or sometimes easier to do the cubed root first, makes the numbers smaller. So the other version is to do this first and then multiply by 4 afterwards, right? Okay, so we've seen something like this before that is on the inside. What do you do? Going back to like first day or second day? Yeah, factor it. So 8 turns into what? 2, 3 times. Yeah, that's it. So we get something like this. The cubed root of 2 times 2 times 2, all to the power of 4. Because it's cubed root, these 3 2's go together, right? They go to the outside. Remember the circle? So that goes like that. Again, for teaching purposes, empty now, right? Remember that? Okay, so that just leaves 2 on the inside now to the power of 4 like that. Break out your fingers and toes. 8 4 over 3 is now equal to 2 times 2 times 2 times 2, 16. Yeah? Yeah. Comfortable with that? Okay, that's all I want to do is with this today, unless something else shows up on the screen, but I don't think so. Okay, just a little introduction to that. Yeah, perfect. So moving on with our lives. This is another math fact that you get for free. Okay, there is a way to show this that I might put up. But the takeaway from this is whenever you have a 0 in the exponent, whatever that exponent is on turns into the number 1. So it could have 5 to the power of 0. What is that? 1. X to the power of 0 equals, as it shows on the screen there, 1. There is a little extra bit though. X can't equal 0, otherwise things get weird. 0 to the power of 0 starts to melt some brains, okay? So little math fact there when it comes up. This now gets into the negative exponents, as we wanted to talk about today. Whenever you have a negative up there, the way to get rid of it is to move everything from either the top to the bottom, as you can see here, or the other way around. If the negative's down here, then you move it up to the top and it works out. Okay, that is, it disappears. The only thing that changes is the exponent. Okay, so if you have something like 2 to the negative 5, right? This is the same now. I want to get rid of that negative for some reason. So I move it from the top to the bottom, and I put this 1 up there to make that happen. Okay. Fingers and toes tells me happens to be 32. Okay. A lot of questions, though, are going to say, write your answer with a positive exponent. Okay, so instead of working it out, just leave it at this level here. No need to do that unless they ask you to evaluate it. That's one of the words for finding the number at the end there. Okay. So this can get pretty messy with these negatives. You can have them inside and in fractions and that sort of thing. So let's see what just what we got up here. Oh yeah, fair enough. Sort of a level 1 already. We got a fraction there. Okay, but take a look. X is on the top. To start with, you move it down underneath. All right, it'll get rid of the negative. The Y goes up because it's on the bottom, right? Both those things get rid of the negatives there, leaving this expression here. Okay, now here's the proper way to do it. Or what you're seeing on the screen is sort of inform a shortcut. What you can do is just flip it and it switches. Okay, you have X over Y, I think is there. It's -9, negative N. So you switch the inside. See, Y goes to the top, X to the bottom. And now, by doing that, at the same time, you have a positive N up there at the top. If the fraction is simple, you can do that. Okay, but just to show you in slow motion how that happens. If you start with this thing, this exponent goes to each thing on the inside, just like we did yesterday with multiplying and such. Okay, so watch. So this is the same thing as this. Okay. Now, if you look at these individually, all right, let's move this one down, X only. Because it's on the top and negative, it's going to be on the bottom and positive. Okay. You see, we just X only. What happens with the Y's? Same style now. Goes to the top, plus n over just like that, right? So we're almost there. Just as this n goes to each thing, if it's on each thing, you can pull it out. Put it on everything, right? So you end up getting now, pulling the exponent n out. That now goes on everything on the inside. And we've done the mathy version of the switch that we did at the top there, okay? This is good. First version is good because it's easy to remember. Second version is good for your future math lives. Like there's a lot of explanations given like this, one step at a time, right? So, and you got to get used to all the n's and x's and negatives and all that stuff. That's what that's for. Okay. Take a look at these now. With the brackets to think of as well as this new negative stuff. What's the first expression going to be? Let's see. I think that sounds pretty good to me. That -3, x, it's on the x only, right? Okay, so watch. It's on the x only. That means if we move this underneath, the -3 will turn positive. So it's not -3 anymore. It's officially, it's plus like that. Okay. But then to get it all as one fraction, top times the top, invisible 1 there, times the bottom, invisible 1 on the 2. So you get 2 over x cubed for that one there. Okay. The other one, the brackets capture everything now, right? Okay, so what, to get rid of that negative, what goes to the bottom? Everything. So you get, as a first step, still in the brackets looking like this, right? To take it further, the bracket goes to each number on the inside. So you get something like that. And if they ask you to work it out, evaluate it, do this extra little bit here with the number, and you would get 1 over 8 x cubed like that. Yeah. Again, why? So we can figure out the insurance on cars like we talked about yesterday, right? Okay. This one here, what does it look like? Oh, there's really no instructions. Write with a positive, write everything with a positive exponent. You can expect to see something like that. Right, with positive exponents. What does this expression now look like? Five stays? 5 stays. What about the x? Is it everything? Nah, right. The x goes, so that will be plus 2 down there now. The z goes down. So yeah, that creates a plus 4 there now. But the y, it already is positive, right? So it just stays as it is. So what is that? Y cubed? Y cubed. Done. Okay, everything's now positive exponents. How about this one? What's that? Same thing? Same thing, yeah. The negatives turn to positives. Nice answer. Now, what would be the first step? Expansion. Yeah, it could do. What does that mean? Get rid of the bracket. Oh, yeah. Okay. So for this question, there's two different ways to go. Yes, one of them is to get rid of the brackets. Okay, like we did in the earlier questions. So if we go that way, then to get rid of the brackets is the -4 will go on each of those variables that we see there. So x squared will stay on the first one, and then y cubed on the second one. Okay, what happens next? You could twist them, sure. This one goes down then, this one goes up, right? Okay, so we could do that. So the y cubed now will have a +4 because it's twisted or switched to the top. And then the x2 will have a +4 because it's switched or twisted down to the bottom there. Yeah, good. It's almost there. All right, what can you do next? Last step, basically. Think about yesterday's stuff. Yeah, 4 times 3 because of the brackets in between there, right? Nice. Nicely done. So we get y to the power of what? 12 it is. Good. And on the bottom? 8. Yeah, x to the power of 8. Finished. Just like that. Nice. Okay. Good. So this is one way to do it. I'd like you to notice that there's another way as well. Oh, not with this pen. Maybe with this one. Another way as well. In the beginning, we split up the brackets right away. Okay, from what I showed you a few pages back, so you could do the switch right away. Whatever's on the inside, bottom and top, just flip it upside down. So you could do that first. So just to show you what it looks like, right? Do the switch first. So that's going to look like y cubed on the top, x squared on the bottom. Both have to change, by the way, not just one, otherwise struggles, okay? All right, so they both switch like this. That changes the negative now to a +4 upstairs like that, okay? Then it's like before. This goes into each of them, and you'll end up getting that, that final answer there. Okay. And there might even another way just by depending on what you do inside here, right? But basically using the same tricks all the way along. Okay. Any questions about that one? Pretty reasonable? Okay. As I said, this is practice for some real stuff that I'll show you probably tomorrow. So you see, these are just make-up questions for now. See, for this one, I don't know if I would do each brackets first, because there'd be a lot of brackets. I might do the switch first, and then even simplify the inside first, then split up. I think that's the way to do this one. Otherwise, it's going to be bracket chaos. Okay, so for a strategy for this one here, we'll do the switch first. Then simplify the inside. And then deal with that, what is that? That exponent on the outside. It starts as -2, it'll change to a 2 along the way, right? I think that'll get, that would be a good way to attack this type of question. Definitely using the negative exponents for this one. Okay, so doing the switch first, just because I would get, help me out, 4x squared, what comes next? This will be all be on the top now. It's going to stay as a -5 because the switch is coming from the negative with the 2 there. Okay. So that's going to stay. It goes to the switches, because now it is a +2. Okay. That's the change that we made. Everything else stays the same. They just go top to bottom, bottom to the top. What do we got for the next one? 7x minus 2. Y minus 3. Z squared, no change. But this on the outside, recognize that changed, right? Okay. So now we're going to start taking a look at the inside, the X's and the Y's and the Z's, right? So let's do the X's first. If we move this X to this X minus 2 to the top, it'll be X2 times X2 over there. Yeah. Let's do the X's separately. Let's look at the X's like this. We have X2 over X minus 2. What's going to happen to them? That one can go up. That's right. So it'll be left with X2 times, what happens to this one? Yeah, X2 only. Changes to plus. And so you get what? X4. And this will be on the top, okay? This will be with the 4 there, not with the 7. Okay? Ends up on the top part of the fraction. What about the Y's? So -5 there and a -3 like that. Let's move this one. Move that one up, this one down, and then simplify them, eh? So we got y minus 5, y minus 3. That's a 3 there, that's a 5. So what does this end up looking like? Not multiplying these. And dividing from yesterday. Remember, this means 3 of these y's multiplied together, right? Y times y times y. On the bottom is 5 of them. Yeah. 2 are left, that's right. 3 of them will cancel out with one another. And that will leave y to the 2 on the bottom now. So this y will be with the 7 when we put it all back together. Okay. So let's see next then. What do we got? Maybe we'll update it to this part here. So far, what do we got? 4 over 7 like that. Yeah, then it'll be x to the 4. That's on the top. And then y to the 2 is on the bottom. And now we still have these z's to work on. The last thing. And this has changed from a negative in the question up there to a positive. That was a long time ago now. Okay, so let's take a look at these z's, these last terms. Z minus 3 over z squared. The top or the bottom is positive already. The bottom's positive already, so we'll leave that one there. This one will come down though, right? Okay, so watch. We'll get, that one stays there. And then it's times this one now, which is positive. Nice. From class here, we had Z5 on the bottom, right? Beautiful. Okay, so we're going to update this now with that there. And that will take care of the inside bits. 7 like that, Y2, Z5 on the bottom, plus 2 on the outside. Fantastic. Okay, so what happens next? Well, what happens next is the 2 now. Yeah. The 2 can go in as exponents for each of these now, right? Okay. But they're exponents, so you're not going to get 2 times 4. It's not going to be 8. It's going to be 4 with that, x to the 4 with that 2, 7 with that, y with that being the 2 that's on the outside. It's going to each thing now. Boom. Okay. Everyone's okay with that step there? How and why it happens? This exponent now goes to each piece on the inside, each variable, each number. See, the 4 gets it. X to the 4 gets it. 7 gets it. Y, Z. Last step now is to take care of all these exponents and multiplying, right? How's that looking? Beautiful. So, it's not 8. This is to the power. If it was 2 times 4, that would be 8. This is 4 squared. So that means 4 times 4. 2 4s multiplied together. 4 times 4 is, hey, there we go, 16. What do we get here? X to the power of, brackets in between. That one's 8, right on. The bottom, it's 2 7s multiplied together. 7 times 7? No. 49 I heard. Yeah, I'll take that one. Next one, y to the power of 4. 10 it is. Finished. Okay. Now, there might be a shorter way to do it, eliminating, gentlemen, might be a shorter way, eliminating the side work and all that. you know, but yeah, and after you get good with this, you can take a look on the inside and go, oh yeah, what do we have here? This goes back a couple steps. -5 subtract -3 ends up being a -2 on the top. So you move it to the bottom and you get +2. You get y2 on the bottom. Just working with subtracting integers. Okay. Over here, you get, because it's dividing, right? You subtract the exponents. That was one of the things we did yesterday. 2 subtract -2. 2 subtract -2 is what? The same as 2 plus 2, same as 4. Okay, so you get a 4. Same with the z. -3 subtract 2 gives -5. That would be on the top. So you move to the bottom. Z to the 5 on the bottom, as we just as we had, right? Hey, let's see. What do we got? Yeah, this is more for actual solving. So this will be on the video now, of course, but we'll take a look more closely at this type of question next day. Okay, these are just evaluating some things, right? Next day. Next day. This we had earlier on, just converting. That goes back in time as a review. Okay, so what do we got for today? Today for you, we got just one worksheet available for this this new topic here. Day 7, beautiful. Multiplying exponents, some dividing, some negative exponents in there. Yeah, good quality activities. Okay, right here. Any questions before you get started? You want to do another one of these? Another one? Sure, I'll make one up. Yeah. Let's do one that looks like this. As before, write with positive exponents, okay? So what's it going to look like? Well, it's going to be on the screen, first of all. Do it like that. It's going to look something like 2 over x6, 3x2. y5 and -3. And we'll say cubed like that. Oh, let's make it a -3 altogether. -3. Don't want it too easy for you. Okay, so how are we going to attack this one? Inside first, okay? Taking a look at the 2 and the 3. Anything there? Do they divide into one another? Can they reduce? No, that's finished. The x's, what can those turn into? 6 on the top divided by the 2 on the bottom. Yeah, so what's the rule? What's the situation? I don't know. I forget. What I remember though is that this 6 means there 6x is multiplied. And this 2 means there's see how fast that is? Someone in class goes, oh, it's x4. X to the 4. But yeah, as soon as you visualize all these x's multiplied together, cancel them out with your brain immediately. They divide them out. And then what are you left with? Yeah, x to the 4. Okay. Or if you don't want to have them all spread out, remember the shortcut from yesterday. That is, when you're dividing, you subtract the exponents from one another. Okay. I point that out. This will be useful for the y's that we have now. Okay. For the y, what do you want to do? Switch. That's probably smart, actually. We could switch this. Yeah. So the y to the 5 stays on the top. And this y to the negative 3, what happens? Switches to the top, plus 3, right? Fantastic. Okay, so how many y's do we have now then? Goes all the way there. 4. 5 here, multiplied by 3 over there. So how many in total are being multiplied? You can do the if you like. Or the shortcut. When you divide, you subtract. So when you multiply, which is what this is, times, it's when you add them together. Right? You have 5 in a row here, multiplied by all 3 in a row there. How many are all being multiplied together? 8 it is, right? So the y's, they turn into y to the 8, still with this minus 3 on the outside of everything like that. Oh, there we go. Yeah, that'll be the next step, dealing with this minus 3. But let's just enjoy the y to the 8 for now. That was hard work, right? Switch it to the top, becomes a plus, and then because it's multiplied, we end up having 8 y's all multiplied together. And then now, yes, this minus 3, we can deal with that 2 different ways. We can put it in right away to everything, which means the negative will stick around, and we have to switch them all after. Or let's switch it now. It's cleverer. Yeah, that's smarter to do that. You go switch, gets rid of the negative, then everything's positive, and it's easier on the eye to work with. Okay. So you switch it now. That means the bottom goes to the top, top goes to the bottom. The bottom is the 3. The top is all that other stuff. Okay. And now it's no longer negative 3 up there, but plus 3 like that. Then yes, this goes to each thing. So the 3, the top gets that exponent of 3. 2 gets the exponent of 3. X to the 4 exponent of 3. One step away. Is it 27 now? Starting to work them all out? 3 to the power of 3? Yeah, it definitely is 27. On the bottom, 2 to the 3? 8 indeed. This one here, 12 or 7? Yeah, it's 12 because the bracket's in between, all right? That's the situation. Next to the 12. Multiply when there's a bracket in between. So over here, y to the power of?
8.
It is.
Okay. It's 24.
Yeah, indeed it is. 24 finishes it up. Okay, so any questions about that one there? No? All righty then. Looking at the clock, it's almost pie time. So yeah, we'll take a little break. Come back. Got some delightful, hopeful questions for you to get started on. And for you in Zoom, I'll upload the questions to Teams and you can get started. Yeah?
The homework?
What's that?
Homework? You mean homework?
That's right. Yeah.
Oh, okay. Yeah.
Yeah. So class, what do you want? You want to take 7 minutes? All right. Okay, so that'll be it for the recording today. Stop that.